Assalamualaikum warahmatullahi wabarakatuh. We are from Group 5. We present an assignment project for the subject of Mathematics and Engineering. Before starting the presentation, we will introduce ourselves.
My name is ABDUL WALDAN bin SASTRI. My metric number CN240197.
My name is FARAH IZAZI Binti HAIRULANUAR. My number metric is CN240355.
My name is ALIYA BATRISYA Binti RAMLEE. My matrix is AN240091.
My name is NURSHAMIRA binti ABDUL Malek. Nama matric is CN240116.
My name is NABILA binti AZLI. My matrix number is AN240042.
Hi, my name is NURSHAMIRA binti ZAKARIA. My matrix number is CN240153.
My name is UZAIR ZAIDI and my matrix card number is CN240293.
My name is MOHAMAD bin RAZAK. My card matrix number is CN240016.
Assalamualaikum warahmatullahi wabarakatuh. My name is ZAIDI. Now, I will explain about the question number 1. A camera mount at point 3000 km from the base of a rocket launching pad. Refer to figure 1. If the rocket is rising vertically at 180 km per second, when it is 3000 km above the launching pad, how fast must be the camera elevation angle changed at the instant to keep the camera aim at the rocket? Okay, based on the question and diagram, the information that we obtain is the camera is 3000 km from the base of the rocket launching pad. Second is the rocket is rising vertically at dh per dt equals to 800 km per second. At the instant when the rocket is 3000 km above the launching pad, h equal to 3000 km. We want to find dh per dt, the rate of change of the elevation angle. For the solution, there are 4 steps that we need to do to get the answer. The first step is using the right triangle, tan theta equals to h per 3000. So by using the right triangle, we get the theta equals to 45 degrees. Second step is differentiate both sides with respect to time to relate d theta per dt and dh per dt. After we differentiate, we will get secant squared theta multiply d theta per dt equals to 1 per 3000 multiply dh per dt as an equation. Step number 3, solve d theta per dt. So when h equals to 3000 km, tan theta equals to 1. So theta is 45 degrees. By using tan theta, so we get the secant squared theta equals to 2. Step number 4, substitute the value. So after we substitute that, so we get the rate of change of the camera's elevation angle is 0.1467 radians per second.
I will present to you question 2. The question is sand of the ground at the constant rate of 110 meter cubic per minute, forming a cone shape with a radius that always 3 times height. Calculate the height of sand changing rate when its height is h equal to 10 meter. Given data, sand fall at dv per dt equal to 110 cubic per minute. The cube radius r equal to 3h. And finally, we want to find dh per dt when h equal to 10 minutes. Formula that we use is volume of cone. V equal to 1 per 3 pi r square. Differentiate volume that we use is chain rule of rate of change. Differentiate V equal to 3 pi h cube. With respect to t, dv per dt equal to 9 pi h square dh per dt. Solution for dh per dt. Given dh per dt equal to 110 meter cubic per minute, h equal to 10 meter. Substitute into dh per dt equal to 9 pi h square dh per dt. 110 equal to 9 pi multiply 10 square dh per dt. dh per dt equal to 11 per 19 pi. The answer for the rate of change of the height of cone is 11 per 19 pi meter per minute or 0.3840 meter per minute.
Today I will analyze a cubic function and cover the following topic: extrema point, the inflection point, and interval of increase, decrease, concavity, and visualization of the graph. To determine extrema point, first, calculate the first derivative of the function f(x). Second, set f(x) equal to 0 to find the critical point. The critical points are x equal to a and x equal to b. And the last, substituting this critical point into the original function f(x). So I found a maximum at a, fa, and a minimum b, fb. To identify the inflection points, first calculate the second derivative of the function f(x). Second, setting f(x) equal to 0, the inflection point occurs at x equal to c. And third, x equal to c into f(x), the inflection point is cfc. So, to determine where the function increase or decrease, first, analyze the sign of f(x). The function increasing on PQ. Second, the function is decreasing on QR. To determine the concavity of the function, I analyze the sign of f(x). The graph is concave up on UV and the graph is concave down on VW. This graph summarizes the analysis. The extrema points are labeled as red dot. Second, the inflection point is marked as a green dot. And the last one, the interval of increase, decrease, and concavity are clearly shown. In conclusion, I analyzed a cubic function by identifying extrema and inflection point. Second, determining interval of increase, decrease, and concavity. And the last one, summarizing this result in a graph.
The first question is A. Integrate 2x power of 3 minus 4x power of 2 minus 15x plus 5 per x power of 2 minus 2x per 8. This question we can use as a partial fraction, and the A is x minus 4 plus b per x plus 2. And we can get the final answer as a slide, and we can get the x power of 2 plus 3 per 2 ln x minus 4 minus 1 per 2 ln x plus 2. Question B, integrate sine 2x dx. We know sine 2x is 1 minus cos 2x per 2. And then after we integrate, we can get 1 per 2, the captivity x, minus sine 2x per 2. And the final answer is 1 per 2x minus sine 2x per 4 plus c. And for the question C, integrate cos 2x dx. Cos 2x is 1 plus cos 2x per 2. And after we integrate, we can get 1 per 2, the captivity x, plus sine 2x per 2. And the final answer is 1 per 2x sine 2x per 4 plus c. Question D, integrate sine power of 3x dx. We can separate integrate sine x times sine power of 2x dx. And then we can get negative, integrate the captivity 1 minus u power of 2 and du. After we integrate, we can get negative, the captivity u minus u power of 3 per 3. And the final answer is negative cos x plus cos power of 3x per 3 plus c. So the question for E, integrate cos power of 3x dx, we can separate integrate cos x times cos power of 2x dx. And then we can get integrate 1 minus u power of 2 du. And we can get u minus u power of 3 per 3 plus c. And the final answer is sin x minus sin power of 3 x per 3 plus c. So for question F, integrate sin power of 2x cos power of 2x dx. And then we can get 1 per 4 integrate 1 minus cos 4x per 2 dx. And we can get 1 per 8 the captivity x minus sin 4x per x. And the final answer is 1 per x minus sin 4x per 32 plus c. For the question G, integrate sin power of 3x and cos power of 4x dx. We can get integrate sin power of 2x, cos power of 4x and sin x. And then we can get integrate the captivity 1 minus u power of 2 and times with u power of 4 du. And we can get negative u power of 5 per 5 minus with u power of 7 per 7 plus c. And the final answer is we can get negative cos power of 5x per 5 plus cos power of 7x per 7 plus c. So for the question here, integrate sin power of 4x cos power of 5x dx. We know cos power of 4x is 1 minus sin power of 2x and the captivity with power of 2. And we can get integrate u power of 4, the captivity 1 minus u power of 2, and we expand the captivity of 1 minus u power of 2. We can get u power of 5 per 5 minus 2 u power of 7 per 7 plus u power of 9 per 9 plus c. And the final answer we can get sin power of 5x per x minus 2 sin power of 7x per 7 plus sin power of 9 per x per 9 plus c. I integrate sin 2x cos 3x dx. We using the equation for sin A cos B equal to 1 per 2 the captivity sin A plus B plus sin A minus B. And we can get 1 per 2 sin 5x plus sin negative x dx. And we integrate the equation for 1 per 2 sin 5x minus sin x dx. We can get 1 per 2 the captivity negative 1 per 5 cos 5x plus cos x. The final answer is negative 1 per 10 cos 5x plus 1 per 2 cos x plus c. For question J, integrate sin 3x sin 5x dx. We use sin A sin B equal to 1 per 2 the captivity cos A minus B minus cos A plus B. And we can get 1 per 2 cos 2x minus cos x. And we can get 1 per 2 sin 2x minus 1 per 8 sin x. And the final answer is 1 per 4 sin 2x and minus with 1 per 16 sin x plus c. Question K, integrate tan power of 2x secant power of 4x dx. We know secant power of 4 is 1 plus u power of 2 the captivity power of 2. And we can expand the 1 plus u power of 2 the captivity power of 2. And we can get u power of 3 per 3 plus u plus 2 u power of 5 per 5 plus u power of 7 per 7 plus c. And the final answer is 10 power of 3x per 3 plus 2 10 power of 5x per 5 plus 10 power of 7x per 7 plus c. Question is L. Integrate 10 power of 3x second power of 3x dx. We can get integrate second power of 2x minus 1 and 10x second power of 3x dx. And the answer is we can get integrate u power of 6 per 6 minus with u power of 4 per 4 plus c. And the final answer is second power of 6x per 6 minus second power of 4x per 4 plus c.
Now I will explain the question number 5, which is the question is a solid is obtained by rotating the region bounded by the curve y equal to 4x and y equal to x power of 3. About the y-axis, assume that x more than equal to 0. So the first question is sketch the bounded region manually. I sketch the graph using a word, and I also use the table method, which is that we assume that x equal to 0 and x equal to 2. So we will got the y value. And from that value, I sketched the graph. And so that was the graph that we got for the answer. So for the question B, sketch the revolution using any mathematical software. So I use GeoGebra as the software that we can draw the solid of 3D. So firstly, we need to insert the equation, which is that y equal to 4x and y equal to x power of 3. So we will got the round shape, which is that we can see at the manual graph that we just got the shape from area under the curve, right? So we will got the round shape on the y-axis. So for the question C, hence calculate the volume of solid using method of cylinder. So the first equation we got is integrate 0 to 2 pi x times 4x minus x power of 3 dx. So we need to multiply the x on the bracket, which is that we got integrate 0 to 2 pi for x power of 2 minus x power of 4 dx. So we need to move the 2 pi in front of the equation. So we got the 2 pi integrate 0 to 2 times 4x power of 2 minus x power of 4 dx. So we need to integrate the bracket, which is that we got 2 pi for x power of 3 per 3 minus x power of 5 per 5. So from that equation, we need to substitute the value of 2 and 0 on the equation. So we will got the 2 pi times 4 times 2 power of 3 per 3 minus 2 power of 5 per 5. So we will got the answer is 2 pi times 44 per 15. So the final answer for this question is 128 per 15 pi cubic.
Assalamualaikum warahmatullahi wabarakatuh. My name is Abdul Daniel Waldan bin Sastri. My metric number is CN240197. Today I will present my question for mathematics project question number 6. And the question sounds is a solid is obtained by revolving the region bounded by the curve y equal to 2x power 2 and y equal to x power 3 about the x-axis. So the first question is sketch a bounded region manually. So I use manually sketch by my iPad and using the notes to sketch the graph manually. So as we can see, the blue color is y equal to 2x power 2 and the red one is y equal to x power 3. The next question is sketch the solid of revolution using any mathematical software. So basically I use the Desmos software on the website. It's free. And first is he insert the first equation, y equal to 2x power 2, and then the graph is like U shape, and then we insert another one equation, y equal to x power 3, so seems like S curve. The last question, question C, hence calculate the volume of the solid using the method of disc or ring. First of all, we need to simplify the terms inside the brackets. The square of 2x power 2 is, we got 4x power 4, and then the square of x power 3 is x power 6. Substituting this, that can get v equal to pi integrate 4x power 4 minus x power 6 bracket and dx. Next is integrate term by term. So we integrate of 4x first. So integrate 4x power 4 dx equal to 4x power 5 over 5. And the second is integrate of x power 6, integrate x power 6 dx equal to x power 7 over 7. So after we substitute this equation, so we get the answer. And then now we evaluate each term at the limits from 0. So the first is 4 bracket 2 close bracket power 5 over 5 equal to 4 bracket 32 close bracket over 5. So the answer is 128 over 5. And then for the next one is bracket 2 close bracket power 7 over 7, and the answer is 128 over 7. So the equation becomes v equal to pi big bracket 128 over 5 minus 128 over 7 close bracket. So we need to subtract this fraction and we need a common denominator. So the least common denominator of 5 and 7 is 35. So we will write the 128 over 5 as 896 over 35. And then we write the 128 over 7 as 640 over 35. Now we subtract the fraction. So 896 over 35 minus 640 over 35. So the answer is 256 over 35. So the last answer is the volume becomes V equal to pi 256 over 35. Yeah, so the last answer is V equal to 256 pi over 35. So that is the volume of the solid revolution. Thank you.
Hi, my name is MOHAMAD bin ABDUL. My cut matrix number is CN240016. For this assignment, our group give me question 7, which is the question is find using dy dx by any mathematical software hyperbolic function, inverse trigonometry function, and inverse hyperbolic. For my part, I'm using for question A until H, I'm using symbol apps maths. I until X, I'm using photomath for answer this question.
So for question 8, we need to find the following integral using any mathematical software. So for this question, I use Photomath as my mathematical software to solve this question. For the first question, we use Photomath to solve it. And we just need to scan the problem. The question was about the integral of dx over 1 plus 3x squared, and the answer is square root of 3 times arctangent of square root of 3x over 3 plus. For the second question, we use Photomath to solve it, and we just need to scan the problem. The question was about the integral of dx over square root of 1 minus 9x squared, and the answer is arcsine of 3x over 3 plus. For the third question, we use Photomath to solve it, and we just need to scan the problem. The question was about the integral of dx over 4 plus 9x squared, and the answer is arctangent of 3x over 2 divided by 6 plus c. For the question 4, we use Photomath to solve it, and we just need to scan the problem. The question was about the integral of e to the power x divided by the square root of 1 minus e to the power 2x with respect to x, and the answer is arcsine of e to the power x plus c. For the question 5, we use Photomath to solve it, and we just need to scan the problem. The question was about the integral of e to the power x divided by 1 plus e to the power 2x with respect to x, and the answer is arctangent of e to the power x plus c. For the question 6, we use Photomath to solve it, and we just need to scan the problem. The question was about the integral of arcsine of x with respect to x, and the answer is lone bracket of tangent of x divided by 2 plus c. For the question 7, we use Photomath to solve it, and we just need to scan the problem. The question was about the integral of tan of x with respect to x, and the answer is lone bracket of sine of x plus c. For the question 8, we use Photomath to solve it, and we just need to scan the problem. The question was about the integral of dx over square root 4x power of 2 minus 9, and the answer is 1 over 2 multiply lone bracket of x plus square root 4x power of 2 minus 9 over 2 plus c. For the question 9, we use Photomath to solve it, and we just need to scan the problem. The question was about the integral of dx over square root 1 plus 9x power of 2, and the answer is 1 over 3 multiply lone bracket of x plus square root 1 plus 9x power of 2 over 3 plus. For the question 10, we use Photomath to solve it, and we just need to scan the problem. The question was about the integral of 1 over square root 1 minus exponent power of 2x, and the answer is 1 over 2 multiply lone bracket of square root 1 minus exponent power of 2x minus 1 over 2 multiply lone bracket of square root 1 minus exponent power of 2x plus 1 plus c. For the question 11, we use Photomath to solve it, and we just need to scan the problem. The question was about the integral of exponent over square root 16 minus exponent power of 2x, and the answer is lone bracket exponent power x plus square root exponent power 2x minus 16 plus c. For the question 12, we use Photomath to solve it, and we just need to scan the problem. The question was about the integral of dx over square root 3x power 2 plus 2, and the answer is square root 3 over 3 multiply lone bracket of x plus square root 9x power 2 plus 6 over 3 plus c. For the question 13, we use Photomath to solve it, and we just need to scan the problem. The question was about the integral of dx over square root 4x power 2 minus 1, and the answer is 1 over 2 multiply lone bracket of x plus square root 4x power 2 minus 1 over 2 plus. For the question 14, we use Photomath to solve it, and we just need to scan the problem. The question was about the integral of exponent power of 3x over square root exponent power 6x plus 25, and the answer is 1 over 3 multiply lone bracket of exponent power 3x plus square root exponent power 6 plus 25 plus c. For the question 15, we use Photomath to solve it, and we just need to scan the problem. The question was about the integral of exponent power 2x over square root 1 plus exponent 4x, and the answer is 1 over 2 multiply lone bracket of exponent power of 2x plus square root exponent plus 1 plus.
That's all from us. Thank you to Madam Azila.